This is a circuit that you can find on more than one places on the World Wide Web. It is a kind of minimum components flasher, and it's also used as an oscillator for higher frequencies. I found it after a few experiments. I had thrown it away in my junk box, but my idea was, well, let me tell more about it. And I made, like I always do, this say very simple setup. It works now on 3 volts. I did more experiments with white LEDs, and in that case it could work on 12 volt, between 12 volt and approximately 17 volts. But the problem is that I cannot reproduce it because I don't know whether I have soldered these LEDs here. These are 3 white LEDs in parallel or in series. So I have to say test that out in a better way, though the whole setup worked in that way with these 3 white LEDs. I now say have scaled it down to a circuit that works on 2 batteries of 1.5 volts Panasonic. Anyway, so together 3 volts, and that is here. Want to demonstrate it? Of course, I know that now at the moment you can buy LEDs that flash by themselves, so you absolutely don't need this circuit. It's pure for fun, entertainment, to learn something about how transistors work, etc, etc. You can make this setup in say 10 minutes on a breadboard without soldering, etc, etc. Most important things to tell is that when you want to make it in this way, this is the way that it always works. 2.2 microfarad non-polar. You can also use an electrolytic, and when you study this schematic you can surely see here that electrolytic. Of course, when you make the capacitance higher here, the frequency will go down, and also when you change, say, the value of this resistor to the base, the frequency will also change, because when you close this switch the capacitor is easily charged up, gives out its voltage in the flash, etc, etc. But this is perhaps a typical and interesting beginner's schematic, and it worked quite nice. And it takes at the moment only a tiny current, I have to say, and that's very strange, but there is an explanation for that. When I switched my ammeter to a more sensitive value here, this is what's happening. An enormous current, the LED starts to light up constantly, no flashing any longer, and that means it has the consequence, as far as I know, I've made these types of circuits more in the past, that when the batteries get depleted, the flashing stops and the LED will constantly light up. Anyway, the current that it takes is tiny. It's now on the 60 milliampere scale, so we are on the 3 milliampere at each pulse. That makes it interesting. Well, I've now connected the 4.7 microfarad. Let's disconnect it. See what happens. Well, now we have a much quicker flash. Of course, it doesn't synchronize properly with the ratio of my camera, but anyway, it flashes very quick. And again, another way to make the flickering smaller in time, that's what I mean, or somewhat longer in time, is to here switch one of the capacitors that charge the capacitor, sorry, the resistors that charge the capacitor out. So also in that case you will see that that works. Not very good visible, by the way. I think it interferes with, say, the frames ratio of my camera, but it flickers now approximately 3 times a second. So anyway, thanks for watching. It's only, say, a very simple beginner's circuit, but one of the ideas of my YouTube channel is, of course, say, to do experiments and show simple circuits that everyone can make, and say get enthusiastic for this beautiful, beautiful hobby, the electronics hobby. And of course I know nowadays everyone works with Arduinos, Raspberry, etc, etc, but well, that's not my cup of tea. I like to do these perhaps in a simple way, stupid, old school, analog experiments. Thanks for watching. When I have time, I will also publish the flasher with white LEDs on 12 volts. It interferes with my camera anyway. Hope it's clearly visible.